In Lesson 8.4, we're going to learn about how to multiply vectors, and there are actually two different ways to multiply vectors. One's going to be called the dot product, and one's called the cross product. Each one has a different purpose and a different procedure for how to do it. So let's start with the dot product. The dot product will tell you whether or not two vectors are perpendicular. And you can do the dot product with 2D vectors, which are ordered pairs, or you can do the dot product with 3D vectors, which were ordered triples. Either one works, and either way, the answer that we get is going to tell us whether or not it's perpendicular. The way that you can tell you're doing the dot product is if there's a little dot in the middle. So here's an example of a dot product, 2, 3, dotted with 5, 7. The dot product is the easier of the two procedures to do. To do the dot product, you just need to multiply the x's, multiply the y's, and add those two things together. So we're going to do 2 times 5 plus 3 times 7. And we're just going to get some number out of that, and that number is the dot product. So in this case, the dot product is 31. And how does that tell us whether or not the two vectors are perpendicular? Well, the rule is if the dot product equals 0, they're perpendicular. If the dot product equals anything other than 0, then the vectors are not perpendicular. So in this case, the dot product's 31. That means the vectors are not perpendicular to each other. It's also not a case where, oh, it's kind of close to 0, so it might be close to perpendicular. No, it's just strictly perpendicular or not perpendicular. A dot product of 1 wouldn't mean that it's almost perpendicular. It still just means not perpendicular. Maybe close, maybe not close, but not perpendicular. Now the way the question's going to look on the test, it won't look like this example where it has the dot right in the middle. You'll have some on the homework that look like that. But what it's going to stay on the test is, are these two vectors perpendicular? And you're going to need to know that that question means do the dot product. So you have to make that connection very, very strong. If you want to know two things are perpendicular, do the dot product. So let's ask it that way for this second example. Are those two vectors perpendicular? See if you can do that one on your own, and then we'll compare answers in just a minute. So again, you multiply the x's, multiply the y's, and add them together. So you should end up with a dot product this time of 0, which means that these vectors are perpendicular. And make sure if the question says, are they perpendicular, that you at least answer with yes or no, not just giving me the number for the dot product. Now this also works in 3D, and it's the same process in 3D, except there are 3 things to multiply. Multiply the x's, plus multiply the y's, plus multiply the z's. But it's the exact same process with the exact same result. If the dot product is 0, the vectors are perpendicular. If the dot product is anything other than 0, they're not perpendicular. See if you can figure that one out on your own. So for your dot product, multiply the x, multiply the y's, multiply the z's. You should get a dot product of -11, which is not 0, so no, the vectors are not perpendicular to each other. Same process for 2D and 3D when you're doing the dot product. The cross product is a little bit different, and it answers a different question. The cross product is going to give us a new vector that is perpendicular to both of the original vectors. And that's kind of a strange idea to think about, because as we probably start to think about it, we're thinking in 2D, and it's not going to work in 2D. If I have 2 vectors here, any 2 vectors, if I'm just thinking flat 2D, there's no way for me to make a third vector that's perpendicular to both of them. I could make a vector that's perpendicular to one of them, but it's not perpendicular to both. The only way to make it perpendicular to both is if I somehow come out of the board, so imagine it coming straight out towards you, then it would be perpendicular to them. Or if you imagine that this is a drawing in 3D and that other vector is kind of going backwards, then you could maybe see how these three vectors are all perpendicular. This one's perpendicular because it's going straight up, and that one's also kind of perpendicular in a 3D sort of way. If you imagine that the red one is pointing kind of out of the page and the two black ones are sort of flat. But the cross product only works in 3 dimensions. You cannot do the cross product for 2-dimensional vectors. In the problem, the way you're going to know it's a cross product is because there's a cross or an X in between the two vectors as opposed to a little dot. So visually, when you see the problem, that's how you know the difference between a cross product problem and a dot product problem. The cross product is a little bit more complicated to compute, but we can figure it out. It's going to involve something that we learned earlier, which has to do with matrices. And we're going to end up having to do the determinant of a 3x3 matrix, and you have to do it by hand because there are variables in it. So you can start by kind of making a matrix, and the top row of your matrix is going to be I, J, and K, which are the unit vectors. When we wrote it as the sum of unit vectors, we put the I, J, and K at the end. That's where that I, J, and K is coming from here. And then below that, you put your two vectors, really in either order, but I like to put the first one first and the second one below that. So that 0, 3, 1 was the first vector, and that was the middle row. And the 0, 1, 2 is the second vector. Now when I made my matrix there, I did not put the little corner brackets on the top and on the bottom, and that's because this is the determinant of the matrix. When you just have kind of an absolute value sort of symbol, that means you're figuring out the determinant of the matrix. And back way earlier in the year, we learned a couple different methods for finding the determinant. One of them involved recopying the first two rows off to the side, and then you were doing long diagonals from left to right, minus long diagonals from right to left. That was one way to do it. You can certainly do it that way. The way I'm going to show you is with the thing that's called the minors, which is where you put a plus, minus, plus on the top. And then what you're going to do is you're going to do I times the determinant of the minor, which is the 2x2 matrix that's left after you kind of ignore the row and the column that I is in. So it'll look like this. It'll be I times the determinant of this 3, 1, 1, 2 matrix that's left over in the corner when we ignore the row and the column that I is in. And a 2x2 matrix is much easier to find the determinant of. For a 2x2 matrix, to find the determinant, you multiply on the main diagonal, and then you subtract what you get when you multiply on the off diagonal. So you do 3 times 2 minus 1 times 1 to get the determinant of that matrix. So when everything is said and done there, we'd end up with 5i. And then we repeat the process for j and for k. So it's the same idea for j, except for it's going to be minus j, or a negative, whatever we get when we do the determinant. We're going to ignore the row and the column that j is in, and we'll be left with a 2x2 matrix 0, 1, 0, 2. And we're going to do the determinant of that one also. Now because of all the zeros there, when you're multiplying in both directions, everything really just ends up canceling out. Same thing with k, it's plus k times the determinant of the little 2x2 that's in the corner there. And again, for the 2x2, you're going to cross multiply, kind of make that fish sort of shape. 0 times 1 minus 3 times 0. And then what you get is your answer for the determinant. So one way to write your answer would be 5i minus 0j plus 0k. It's sort of a coincidence that so many zeros are there. Typically you will have numbers for several of those. But because there are zeros, you could just write it as 5i. You wouldn't need the 0j and 0k. And remember, that's called the sum of unit vectors. The I, j, and k is what we use when we have unit vectors. You could also rewrite this as an ordered triple. The ordered triple would be 5, 0, 0. So either form of your answer is good. Now, some of the questions in your homework are going to say, find a vector that's perpendicular to both. That's what we did. And then check and make sure that it is perpendicular. Well, we learned earlier how to check and see if something is perpendicular. That's the dot product. So if I wanted to check my work and make sure that 5, 0, 0 was perpendicular, I could do the dot product with each of the original two vectors and make sure that I got 0 at the end. And as long as you did everything right, you should get 0 at the end. That's the cross product. That's the whole process. It only works in 3D because otherwise you wouldn't be able to make your matrix like that. And to do it, you're doing the determinant. The biggest thing people forget is the plus minus plus at the top. But other than that, it's good. I'd like you to try one cross product problem on your own, and I'm going to ask it the way it'll be asked on the test. Find a vector that is perpendicular to both 2, 3, negative 1, and 1, 5, 0. That's a very test sort of question. It will not look like the last example where it has the cross in between them. It's going to expect you to know, or I'm going to expect you to know, what it means when I'm saying find a vector perpendicular to both. It means do the cross product. Why don't you pause and try to do that one on your own. So let's check your answer. I don't have all the steps written, but you should have gotten the vector 5, negative 1, 7. And what I'd like you to do is check that answer and make sure that it's correct. What we were supposed to get here was a vector that's perpendicular to both of the original ones. So if we're going to check it, we'll do the dot product. If I want to make sure that my answer, 5, negative 1, 7, is really perpendicular to the first vector, I can do the dot product and make sure that I get an answer of 0, which I do. I also want to check and make sure that my answer is perpendicular to the second vector. And if I do the dot product and check, I get another dot product of 0. So yes, that vector 5, negative 1, 7 is perpendicular to both. So the two big concepts in this lesson were dot product and cross product. The way the questions are going to look on the test, if I'm asking you, are they perpendicular, you should do the dot product. If I'm saying, like this one that's on the board, find a vector that's perpendicular to both, you should do the cross product.